So hello, welcome back everyone, and welcome to the rest of the program. Actually, the last part of this conference, which will be dedicated to artificial intelligence. In this session, we'll first have a session on how publishers are currently applying AI in their workflows. And this session is moderated by Jabe Wilson. Jabe is the Global Commercial Director, Data and Analytics at Elsevier. And Jabe will also present the results of a survey that was held earlier this year on behalf of STM. After that, we'll have a session and panel discussion on the AI ethics white paper that was released today, and we will share a link to that document later today. But first, the word to Jabe.
Thank you, Joris. So we have an action-packed session today. We're going to be talking about the use of AI in publishers' workflows. As Joris said, first of all, I will talk a little bit about the survey which was recently undertaken to understand the ways in which AI is supporting publishers' businesses. And then we're going to have a lightning style presentation session where we will be talking about the different ways that diverse publishers are using AI in their businesses. So we have presentations from Sonia Crane from the American Chemical Society, Matthias Astel from Ndawi, Scott Dinnan from the Optical Society, and Marcel Karnstedt-Holpert from Springer Nature. And I will also present briefly about Elsevier. So I'm now going to present a little bit about the survey results from the work we've done in reaching out to STM members. And this was part of the work done to produce the AI ethics and scholarly communication white paper. The intention here is to really understand the ways in which STM publishers are working with AI, which is a relatively new endeavor for the publishing business, and to ensure that we have, if you like, a seat at the table when we're talking about the practices and principles of applying AI. So this survey was undertaken over a period of several months to reach out to publishers to get them to report on how they are actually using AI to support their businesses. And really what we're seeking to do through this is to understand the ways in which AI is impacting publishing businesses, the ways in which the publishers are sourcing ideas, generating programs to support their businesses and to support the scientific researchers which we serve within publishing. So we're seeking to understand the ways in which these are being leveraged to support the vibrant scientific community. So the first really question we asked is, how are publishing organizations using AI? And I think an interesting aspect here is AI is a nascent technology, and publishers are using this to enhance their existing business right now, their existing products, and also to some extent in the use of internal systems to support the publishing process. But what is not the case right now is there's not a very large uptake in terms of focusing on licensing scientific content for the development of AI systems. So that's definitely something which will be developed, but right now the focus of STM publishers is really on their current products. And this is really backed up when we asked about the goals of publishers. There's a range of activities here, but really it's about enhancing the existing business rather than developing new business models. So supporting the publishing process, supporting our operations, and enhancing the products which we offer to our customers, but less on developing a market for this data to be sold into AI systems, and less actually in terms of developing revenue generating products based on AI currently. Now, another question that we asked is, how are STM publishers developing the ideas and the concepts for products and services? And really what we see here, unsurprisingly, is that this is done in collaboration. Either cross-functional teams within our organizations or collaborations with third parties. And this is not unsurprising when we consider that the collaboration required for developing AI systems is really around bringing together domain knowledge and data science expertise. And so this is clearly where, as publishers, we have a role to play with our expertise in our domain knowledge in specific fields, and bringing together that with data science capabilities. And the next question that we ask really is, how are STM publishers developing AI within their organizations? And I think an important element here is that publishers are actually bringing this expertise in-house. Working with consultants is clearly a usual route to developing these products and these services, as well as working with vendors. But actually what we're seeing importantly within the STM community is that publishers are actually developing these capabilities themselves and bringing this in-house. And I think this is an important message when it comes to us as a community, stating that we have the right to have a seat at the table when AI questions are being discussed, because it's clear that organizations are building those capabilities into their organizations. And that's something which we'll be talking about shortly in the presentations today. So finally, the question was posed as to how should the STM Association support the publishing community? And we can see, unsurprisingly, that there's a real interest in structuring a framework in which we can operate in various ways. And in particular, AI ethics, so ensuring that AI systems are used ethically within both the publishing processes, but also the way in which that information is then used, and also in facilitating best practice in the ways in which that data can be made interoperable and shared in a way which enables progress to be made. So the fair data principles is really a key area in which we can make progress. So that hopefully gives you a brief insight into the outcomes of the survey which was undertaken, and the perspective that it gives you on where publishers are right now in terms of their use of AI. It was a very short whistle-stop tour through that, and you'll also be able to read the white paper. But now we'll be moving into the session where we give you some meaningful illustrations of how publishers are working with this data and working with AI within their businesses. And I will do my best to keep us on time. We've got a short time session for this. And so I'll now hand over to Sonia Crane from the American Chemical Society.
Thank you. There we go. All right, let me share my screen. All right, I believe you should now be able to see the title slide. Let me know if that's not the case, please. I want to start by saying thanks for the invitation to share with you some of the ways in which ACS is using artificial intelligence to support the editorial peer review process. This chart summarizes the various stages of the overall process, and it highlights some of the ways in which artificial intelligence might be used. As you can see, each step in the process could benefit from some type of AI application. I won't go into details here, and my fellow speakers in this session will actually be covering other aspects of using technology within this process. So in the following slides, we'll take a high-level look at an AI application to journal selection, specifically manuscript transfer. Before describing the tool we currently have in development, I wanted to take a look back a bit at our interest in manuscript transfer and how it is developed across our journal portfolio. ACS Publications actively surveys authors for insight on a number of topics related to the publication process. We offer a survey to corresponding authors at the time of final decision so that we can collect systematic and longitudinal data. We saw in some early responses, back before manuscript transfer was a core part of the ACS's publishing program, that authors have an interest in manuscript transfer, and it's something they'd like to be offered as authors with our journals. We also have some data on what was going on before ACS journals introduced formal manuscript transfer. Using a tool that matches manuscript metadata with the published literature, we could form a much clearer picture of the fate of manuscripts that were declined by our editors. An analysis of manuscripts rejected by ACS journals way back in 2015 shows that 2/3 of those manuscripts were published in the following 2 years, and the 3 arrows represent those articles. What's notable is that the majority of those articles appeared in non-ACS journals, and these are authors who they initially elected to submit their manuscript to ACS, but ultimately published in a journal from another publisher. That's probably a more difficult author experience than we'd hoped for. And from a publisher perspective, it represents a significant loss of our investment in the peer review of these manuscripts. So we introduced manuscript transfer in a very open way. Many authors were offered the option to select any other ACS journal for their transferred submission. Let's take a quick look at what happened. And the upshot is this: during the author picks era, authors didn't always select the most appropriate next journal for transfer, and in fact seemed to follow an impact factor cascade. So as a result, receiving journals ended up rejecting a very large majority of manuscripts that were transferred in, which is really frustrating for authors and editors alike. With a quick pivot and subsequent adoption of an editor-guided transfer process, the rejection rate stabilized around 45% overall, with really dramatic increases in rejection after editorial review. So it's a lot better, but still with room for improvement. With this change, absolute numbers took a hit, likely because we were asking our already busy editors to play a more active role in the transfer process by really familiarizing themselves with the scope of the many journals that they could transfer to, and possibly even consulting with the receiving journal editor. So we really want to find a way to make offering a transfer easy for our editors, so they'll be encouraged to do so. And that's because we know that authors do appreciate those transfer offers. Using the same survey mechanism I described earlier, we looked at author responses based on transfer history, and those results indicate that authors receiving a reject with transfer decision are less dissatisfied than authors rejected without a transfer offer. So these findings have encouraged us to continue working on methods to optimize manuscript transfer for our editors and authors, and the current iteration of that development is the AI-assisted transfer tool. So editors across our 70+ journals can use a standalone interface to identify the most likely transfer destination journals for a manuscript being declined. The algorithm uses text from the manuscript coupled with author history to recommend related ACS journals, and the probability score indicates the confidence level within these search results. What's notable is that not every ACS journal can transfer to any other journal. The results displayed by this tool reflect allowed transfer relationships only. And new journals less than 2 years into publication and low volume journals that publish fewer than 200 articles a year are queried separately, as the general search results tend to skew in favor of large journals with more extensive publishing history. And outcomes of this have been really positive. That figure I showed of 2015 rejections with a robust pipeline of journals, a robust pipeline of manuscripts being published in journals from other publishers. We now see that about 1 in 4 manuscripts that previously ended up elsewhere now remain with ACS journals. In order to make things easier for our editors, we've recently made available a link at the editorial decision point in our manuscript processing system, which affords editors single-click access to manuscript-specific transfer tool search results. Usage increased dramatically with this change, and we're looking ahead at additional ways in which we can make this and other tools available to our editor and author communities. So thanks again for the invitation to take part in this engaging process, in this engaging conference. And I hope I've been able to share with you just a little snapshot of what we're doing at ACS Publications. And I believe now I am turning it over to Matthias Astel from Hindawi.
Thanks, Anya, and for an interesting look at utilizing AI in a different part of the workflow from what I'm going to be talking about. Effectively, I'm going to be looking at the way in which we've used AI to remove the language barriers for authors. I'm going to start by looking at the problem that we were attempting to solve in the introduction of this AI approach. A large proportion of our authors are non-native English speakers, so roughly 75%, which means that publishing in English creates an immediate and natural barrier for them. Overall, we're attempting to streamline and simplify the publishing process for all of our authors and provide benefits to authors throughout that process, but additionally decrease the burden on editors and reviewers in relation to language. So to help solve this, we've implemented an AI solution at point of submission for authors. The approach that we've taken is a very straightforward author-led process. So currently we, on the journal submission page, present an option to the author to use Writeful, which is the AI part that we're working with, to utilize a language check on their manuscript prior to submission. So it's within the submission system that this option is presented to them, but it is not integrated as part of the submission system. Authors who select to use Writeful are taken to a dedicated system in which they upload their manuscript and receive back a report within, on average, about 3 seconds. That provides them with a number of suggestions covering spelling, grammar, vocabulary, and style. Authors can then choose to accept or reject suggestions directly on the platform and download an updated Word doc version of their manuscript, or they can choose to download the suggestions and go through at their leisure the suggestions made and then submit. We have an automatic return from the site when all suggestions are accepted or rejected that returns the author back to the submission system and enables them to then submit the revised manuscript. So relatively straightforward, not particularly integrated, but utilizing AI in a very tangible manner. We tested the system from June of 2019, and we integrated it into the submission process in June of 2020. Since then, we've had roughly 20,000 authors come through to the site, resulting in 6,000 manuscripts being processed. That's about 10% of our submissions in that time period. On average, the manuscripts receive 100 suggestions, showing that there is a real need for this level of checking prior to submission. And 87% of those, in median, suggestions were accepted, showing that authors engage well with it and value and understand the changes and impact it's having on their manuscript. So not only does it improve the experience that the authors have in providing them a free and easy to use system at point of submission for checking the language, but in terms of the impact on our workflows and the experience of peer review for our authors and editors, we found that the average time to acceptance for papers that were accepted is 20 days lower than the average for other papers from those regions that didn't use Rightful. The number of rounds of review was lower. And we found that far fewer language issues were raised in the review reports or in the editor recommendations. And we also found that for first-time authors, we saw an increase in the number of acceptances when compared against first-time submissions from the same countries. Now, we didn't see a notable change in acceptance rates, but what we did see is more papers moving through to decisions and having less rounds of review. I'm going to end there. I wanted to just demonstrate the impact that the implementation we've had. Going forward, we're going to look at directly implementing the process into submission for all our authors. And I apologize, Gabe, I don't know who I'm handing off to.
Scott there. Hello, everybody.
Right.
This is the first time I've worn a tie since the pandemic started. I'm going to be talking about the Optical Society and our experience with AI for selection. First, a few words about the Optical Society. We have the largest collection of optics and photonics publications, 19 journals, some of them rather large, conference papers from about 800 pages on our own platform. I guess the point is most of the people in optics and photonics publish with us sooner or later. And that will be an important point when we talk about our AI application. Like most of your communities, there's a lot of sub-disciplines in mine, optics and photonics. Think of astronomy, image recognition, telecommunications, biomedical imaging, many other topics. And what authors tell us repeatedly is that one of the things they value most from the society is the ability to find the right reviewers for people who really have the right knowledge to provide review. I'll remind the group what the desired traits typically are in a reviewer of a journal submission. Certainly, we want domain knowledge. We want people who are engaged in their community, whatever the level they are at it. Responsiveness, obviously very important, especially with the pressure to publish quickly. And ultimately, we need a clear, insightful, relevant report. The selection tactics used for reviewers are very effective, the ones we typically see. OSA allows authors to recommend reviewers. I'm sure a lot of you do as well in your publishing houses. Editors, of course, use their personal networks in their main areas to find people. And many of us have tools that allow keyword search or reference search or tactics like that. Now, there's some downsides to sticking with who you know, especially as publishing has become so global. You want to find all the people as candidates. And keyword searches and reference searches are great tools, but at times they can be very inaccurate. They're largely processed. So AI is actually very good candidate to help problem candidate selection. What the Optical Society does is we profile every submitted manuscript. We've also profiled all the published papers to create a thumbprint of each paper. And the next slide, I'll give a little detail about how that works. But the goal is to try to find the people of all the papers that we've published with some parameters, recent papers. Again, a lot of the community has published with some time. And so we know a lot about these people. Were they reviewers in the past? Were they effective? Etc. So, excuse me, I'm just responding to a note here that audio might be so great. Let me see if I can make a quick change here. I'll keep going, but get a little closer. Ultimately, our editors can look at the AI reports that we provide, select reviewers based on those reports. So a little information about how the system works. As I mentioned, we profile submitted manuscripts and papers. There's a lot that goes into the profiling, but what I can show you quickly is that we use controlled vocabulary terms, the source terms. We have software that identifies non-controlled terms, but meaningful terms. And then we throw away the stop words. There's a lot of other things going on. We've been working with Expert System, now Expert AI, formerly Temis, for quite a number of years on the software solution. After this AI enrichment, we're able to provide the editors with a report of the papers and people that match the submitted manuscript. This is a mock-up. Our actual system looks a little different. I just wanted to give you a concept here. The report indicates if there's a conflict. In this case, first published paper is a good match, but the authors match the submitted manuscript. We can get like that, and drilling down into a particular person reveals what we know about that person. For example, we can see the badge that indicates this person was successfully passed our reviewer certificate course. We can see the review history as well. Responsive, but currently busy. So this is the last slide. Just a word about what we could do in the future. Strengthening the similarity service certainly is possible through the new techniques, additional thesauri, etc. One also might consider expanding the universe of papers we look at. One problem with going outside the OSA portfolio is we have a hard time knowing about these people. I suppose the ORCID ID might be able to play a role in some cases. And ultimately, we're looking at metrics that can help us define how effective is this technique, define it. So I apologize for any problems with I'm over to Marcel.
Thanks, Scott. So that's now, let me share my screen. Just a moment. Okay, there you go. Left the meeting. No, wait a moment. Okay, there you go. Okay, so inside Springer Nature, we are applying the AI technologies to a wide range of aspects in our business and workflows, very similar to what we saw in that session before. What I'm looking here now is at how we are applying it in actually building new products on top of publications, database product, facts databases. And what we are doing here is we are centering these databases around the world of entities and their relations. And we do that really from end to end, from content production, database production, up to actually applying and building the product. So to give you a bit more of an insight what we mean by that, one thing, for instance, is smart search. So we're building smart search features that basically you're giving when you're searching on these platforms, you're going into a world of entities. We're trying to guess what you're trying to head for searching. We base it on the properties, on the entities that we identify, and doing that more than just a simple keyword search. This goes then on to aspects of browse, explore, discover, relations between entities, related techniques, as you can see here, but also browsing our content by defining areas of interest, areas of topics, again, based on the entities and their relations. This also holds for the content production. How do we actually get there? So we use entity recognition to actually help our production teams to really annotate our articles, and then up to what we call interactive data, where you can really interact a lot with the data, which is based on the concept of knowledge graphs, that you can really find the right data and do the right interaction. All these that you see here, they are in production. They are driven by AI so far. And at the moment, we are moving this from the world of entity-centric databases actually to a world of data and analytics solutions that are driven and they live from this knowledge that we create and the knowledge structures, I believe similar to what we'll see in a few minutes from Jabe as well. Technically, what does that mean? As I said, it's all revolving around entities, relations, and the knowledge that we create out of that. So in aspects of AI tech, we are dealing with a lot of things around named entity, recognition, linking, resolution, disambiguation, you name it. We look into relation extraction, and then all of this, we can create these knowledge graphs and actually apply the knowledge graphs in our products. In the schema, so this is a lot from end to end, from content to product features. And what I'm talking here is a lot revolving around that circle there of annotating data, of creating, enriching the data, building structured metadata, integrating external data, internal data that is representing our knowledge. And important keywords that we see here is that we do a lot of text mining, obviously, to get there. An important concept that we are following is assisted automation, that really we still have a lot of humans, experts in the loop, but we assist them with machine learning and AI as far as we can. And then all this direction, data modeling, and then, knowledge extraction. And the drivers from our point of view are really the domain expertise that we have. The data quality aspects are extremely important, and an engineering concept, data ops, that really allows us to do all these things in an efficient manner end to end. And then on top of this, you have all these typical AI and machine learning techniques and applications that we're using in our context. Now, maybe the most important thing for us is what did we learn from that? So definitely what we like to do is we like to start with partnering with other partners and then building up the expertise in-house. Because what we learned is that on the long run, the costs and flexibility benefits that we get from doing things in-house are much bigger, and it's absolutely worth to build these capabilities in-house. Key to these capabilities is subject expertise, so that really our domain experts do the right thing, and that's where assisted automation comes into play, that we put their abilities, their expertise into the right spots, into the right points. Initial proof of concepts we like to do with partners, and they should focus on the solution, the applicability, opportunities that we have. But the actual challenge comes when you want to bring these things onto the road, when you really want to solve your problems into your products. And that's where most of our energy goes into, to actually stay focused on the problem and the actual application and use case that we have. Technically, what we learned a lot is that algorithms and technologies are important, but actually it all comes with the data. So the data is important, clean data, clean outcome. Yeah, dirt in, dirt out, absolutely. And also what we do is, also we are trying not to solve only one specific problem, rather we try to build these knowledge structures, knowledge graphs that help us to build generic knowledge and then apply it in different cases. And we also try to reuse as much as we can that's out there, but we also understand that we need to learn, we need to build and tailor things for concrete cases. And I think the most important insight is really that new business, like the database business and beyond, that has to live and has to be enabled by new technology. And we feel absolutely that we are on the driver's seat to also push that and to make that successful. Okay, and with that one, I can stop that and hand over to Jabe, I believe.
Thanks, Marcel. And a big thank you to everybody so far for keeping to time. That's been great. Oh, so Marcel, you need to stop sharing, I think, before I can share my screen.
Apologies for that. There you go. Sorry.
Okay. Thanks so much. Okay. So I'm going to talk about a slightly different aspect here of applying AI. I'm going to be talking about how you can use AI to develop a service or product, if you like, on top of the data. In this case, it's an example of using the Elsevier data to develop an AI system which is able to help in the process of drug repurposing. So this is our life sciences data. We worked on this project in collaboration with the Editorial Alliance, which is a group of pharma companies, the patient advocacy group Mission Cure, and also Cures Within Reach, another patient advocacy group. And this was to seek to identify drugs that could be repurposed for the treatment of a disease called chronic pancreatitis, which currently has no effective treatment or cure, and it's a rather unpleasant disease. One of the symptoms is extreme pain. So just a little bit of background about drug repurposing. Drug repurposing is really an effective way to get drugs to market very speedily and at a lower cost than the de novo development right from scratch. So what I'm going to talk about here is essentially the 5 major steps in building an AI system using data, using publishers' data. And those steps are essentially, the first step is data preparation, so bringing your data together and making sure you can source the right data for the problem at hand. The second step is interlinking that data, so building a knowledge graph, and that allows you to look at the data in different ways to query it as part of your process of building your AI system. The third step is creating what we call AI-ready data, essentially getting your data into a series of ones and zeros, slicing it so it's just the right data required to feed into the machine learning. Step 4 is actually then running your machine learning systems to create your neural network to provide the role that it does as a tool. And finally, step 5 is making that data explainable. So we talk about responsible AI, is putting that tool in the hands of experts, but doing so in a way that is not a black box, but is interpretable and people can understand how it's come to its answers. So the process we followed in this project was data preparation. We pulled together data from a number of our own sources, as well as Open Targets, which is a third-party source. And we filtered that data based on the genes that were known to be associated with this disease. So we filtered down this vast array of data taken from our databases. The next step was, this created a huge knowledge graph, very, very complex, millions of edges. And so we had to simplify that. And we simplified it down to a basic data model where we were looking at 3 real areas: compounds, as in the chemicals involved, the drugs; proteins, the biological targets that the drugs address in the body; and diseases, and that's the background context around the condition. And so step 3 was making this data AI ready, creating slices of the data. And so to do this, we were basically looking at different strategies that are used in drug repurposing. The first strategy is around the scientific method, if you like, predicting what a protein does in terms of regulating the disease. The second approach that you can take is actually predicting how compounds bind to proteins, which is the relatively straightforward approach. And strategy 3 is in getting your arms around all of the data and looking at the overall mechanisms. Now, we chose the second approach here, understanding compounds and proteins and how they interact. Essentially what we did is we took the molecular descriptors for the drugs, the compounds, translated them into vectors, ones and zeros, and we did the same with the proteins, the amino acid sequences, ones and zeros, and then we had from these databases information about which drugs were known to interact with which biological targets. That gave us a huge amount of data, big data as I say. And we then, from this trained neural network model, were able to see which drugs didn't have a known relationship with a target, but were likely to. So we could predict the probability that a drug would connect and interact with a target and potentially intercede in the disease process. The responsible AI session here was to do with when we got our predictions. So the top most relevant prediction we had was a drug called lacosamide. We also looked at adverse events information to qualify that this might be a mechanism that made sense, and gene expression profile data. So these were methods that the expert panel could easily understand. They're relevant to their way of interpreting the data, and it gave them a window on the predictions that our model had made. And essentially what this did, this application of AI on published data, is it allowed us to predict that lacosamide would have an impact on this disease process, and we could do so by predicting that it binded to proteins which were known to be involved in the disease mechanism, in this case CFTR and CTSB. And the next step in this process is that it will be taken to clinical trials to identify whether this is actually a meaningful outcome. And so I think I wanted to talk about this because it just gives an illustration of how AI can be used to do good, and do so in an ethical way and based on publishers' data, and the way that that can be transformed using AI to really have an impact. So thank you for your time, and thank you for the other speakers for sticking to the schedule and giving us some insights into the ways in which AI can be used in the publishing world. So I think we probably don't have time for questions, but I can hand over. I think we've managed to keep it within time, and hand over to Jonas. So thank you very much, everyone.
Thank you, Jay. Could you stop your sharing? Yeah, perfect. Thank you very much. So thank you for this great session. I especially like that we addressed all possible applications of AI in the article workflow, from the submission to the processing to the peer review, to creating content buckets and getting insights. So it was really, really fantastic session, really insightful. So we're up to the next and the last section of this day, presentation and a panel on the white paper, which was released today, and will be shared in a link soon. I wanted to start with this image, because if you ask someone what he or she thinks about AI, chances are you get two entirely different views. One is the utopian. AI will make life easier, safer, people healthier, as we've seen in the last example. And this optimistic, progressive view is also existing in science, fueled by the availability of digital content, including articles, books, data. AI is believed to have the potential to truly revolutionize how science is conducted and communicated. The other view is more dystopian, where images are conjured of surveillance states and social credit systems, facial recognition, racial bias, and addiction to social media, where opaque algorithms exploit human vulnerabilities. But whether we want it or not, AI is a reality today. And again, I want to thank the former speakers, which gave a great insight on how far publishers are at this moment. We've seen AI supporting internal workflows and services. We've seen the building of external facing tools and services. But let's also not forget that we can play an important role as data providers, curated, highly selected data. And in this way, publishers do not only benefit from AI, but AI also benefits from publishers. So the potential and the risks, both the potential and the risks of AI inspired various organizations to define and address the legal and ethical aspects of AI. Building on these general principles, STM felt it would be good and worthwhile to delve into AI. And in 2019, 18 months ago, the association formed a working group to explore the specific perspective that the STM community can bring to this topic. The white paper published today brings together the working group's current thinking on STM publishers, on how STM publishers can contribute to the ethical, trustworthy, and human-centric development, deployment, and application of this technology. Thanks very much to the working group. You see them listed here, and thanks also to all the previous speakers who also contributed to the white paper. And a summary of their applications can be found in the document as well. So with the launch of the white paper today, I'm very happy to introduce a great panel to further discuss its content as well as the next steps. First, and I ask everyone to unmute and open the cameras, Dr. Nanda Piersma. Hello, welcome. Nanda is Professor of Responsible IT at Amsterdam University of Applied Sciences and the Science Director of the Expertise Center of Applied Artificial Intelligence. Currently, she's seconded to the Dutch National Research Institute for Mathematics and Computer Science as Professor of Urban Analytics. She investigates how IT systems could change to create trust in the systems in order to support the digitalization of society. Henning Schoenenberger is Director of Books Publishing Services at Solutions at Springer Nature. And Jack Oakes is Vice President of Strategic Planning Analytics at the American Chemical Society. And both Henning and Jack are the co-chairs of the working group that have produced contributed to this white paper. So before we go into the discussion, we will summarize the most important best practices principles that came out of the working group, and they are grouped in 5 categories. And the first one is transparency and accountability. And I would like to ask Henning to summarize high level what the findings were here.
Yeah, that's fine. Thank you, Joris. And I guess you can hear me, right?
Yes.
Perfect. Yeah, transparency, accountability. I think I think it was very early in our working group that we found that transparency on the one side, accountability on the other side should be at the core of how we want to look at artificial intelligence. I think has a number of aspects that are important. Yours, I think one of the pictures shows that publishers are data providers, and we have heard about this also in the previous talks. I think from that perspective, transparency in data is super important, providing information on where the data comes from and then also how data is validated. I think that is key. But then also transparency about the use of intellectual property and copyright and copyrighted material. I think that's the other side that we think should be also looked into. AI is, and also this we heard today, is very strong in decision making based on pattern recognition and large data sets. So we should be transparent as possible, I would say, where such decision making is taking place, how it works, and then also what it is based on. And I think we should be very, very explicit about when exactly AI is used. We thought in our working group that surfacing bias is very important. It's often incorporated in training data, then identify bias, and then also taking the measures to overcome it. You will find that throughout the white paper. It's also relevant to answer the question then, and that is the other part, who's actually responsible of AI-based decision making. That's the question of accountability. It's a complex one. We found often it's really difficult to understand how deep neural networks actually get to their output and decisions. So clearly accountability lies at the heart of research. Question is it a shared accountability between the developer of the AI and initiator of a given research, and then the one who actually performs the research? We think, and that's also important, we don't have all the final answers yet. But we clearly see signals how important accountability is in AI.
Thank you. Next topic is the quality and integrity.
Thank you, Joris. I think one of the things I would say there are sort of three areas that are of great interest when we think about quality integrity in terms of artificial intelligence. The first one, as we've heard from several speakers today, and I think that most of the people on this call intuitively know, is the quality of the input that goes into the machine training and the algorithms that are being run by the artificial intelligence algorithms. I think Marcel put it very well when he said dirt in, dirt out. In the US, it's garbage in, garbage out, but the concept is still the same. If you put bad data or useless data or data that is poorly constructed into the process, it doesn't matter how good your algorithms are or how many smart people you've got working on it, you're not going to get anything good coming out of it. I think a second aspect of quality is one, again, which is also well known to this group, which is the construction and the process by which the algorithms that are being used in the artificial intelligence are done, but not only done, but also captured, stored, and retained with sufficient documentation so that if someone other than the original creators of the algorithms that are being used has to come in and try and figure out either what happened or what went wrong or how to improve the system, there is a resource there that enables them to come and do that. And the third aspect of it is the output itself. And one of the things that I think I found especially interesting that's integrated into the white paper is when you've completed your AI process, you're not done if you really want a quality AI output. It is a bit, particularly where the AI algorithms and the process is very sophisticated, very complicated, very automated with very little human interaction and intervention into it, and you are relying on that AI output for advice or decision making in decisions that can be very important. You want to check, you want to conduct what would be called in an analog world sensitivity testing or iterative testing to make sure that the outputs of your AI process are in fact good quality. And that includes things like after you think you're done, you put some bad data, you put some biased data into that algorithm that you think, and you see what you get out of it. If your system hasn't detected that data, or if your system goes array in a big way, that tells you that you're not quite there yet. And so throughout the paper, those people who are knowledgeable have advised, and I think it's advice which is well taken, is there should be iterative testing, there should be feedback loops of the outcomes of your AI, especially where there's not a lot of human involvement, to test and make sure that bias has not been introduced in the original process or in a later process, or that you've got something good that can be relied on. And as publishers, one of the things that we are very good at is creating high quality input data. So the only other thing I would add, just not necessarily on quality integrity, I think we should also acknowledge that Elizabeth Nolan of the Optical Society was the co-chair, along with Henning and myself, of the group that did with this, along with about 10 or 15 people who's from houses that are represented on this call who aren't necessarily, didn't necessarily personally participate in the creation of the final paper, but were very much of the process. And in terms of that group, I would also call out Carlos Scola-Lavazari, who is the STM legal counsel, who supplied some really seminal work in getting the group up and going, and Jay Wilson, who very modestly did not mention his own key role in designing, implementing, and creating this very useful questionnaire about which we just heard a presentation. So, sorry, full stop.
Thank you, Jack, adding this quality to there. Thank you very much. Talking about legal, the next topic is privacy and security. Henning.
Yeah, thank you, Jack, for pointing out your points that I think was also important. privacy security. Yeah, also here we STM publishers. I think we think that throughout their life cycle, AI systems should respect and then also uphold privacy rights and data protection. We think that it's important to ensure the security of data sets used in training or then also operating such systems. We think that privacy and data security should be already considered exactly when designing and developing AI systems, and then also when using them. And for example, through anonymization of personal data, similar to a little bit what I said with regards to transparency. And there you see also that our principles really intertwine nicely into each other. The sources of the data should be made transparent. Adequate safeguarding should be in place to avoid corruption of data and bias. Jack, you pointed this also out. And as difficult as this often is to recognize and identify them. And then finally making sure that there is no unintended effects of AI systems. And if that is the case, then take appropriate measures. And also here, Jack, you pointed out a couple of examples how to do so.
Thank you. I think the next topic is very important and frequently mentioned, that is around fairness.
Yeah, and fairness is one that I think is very much a topic of the day. Again, this becomes especially important where AI is used in decision making. I think some examples that we've got in the paper, you have to guard against not only the introduction of bias, but you also have to be proactive in making sure that the contents in and the process is fair to those parts that are involved. And it sometimes is not enough just to exclude some of the obvious things that would be unfair to various groups that are in. In fact, one example that's used in the white paper is one where an explicit factor of age was removed in terms of an analysis to make sure that that was not a distorting factor. But at the same time, instead, there were age-related data points such as educational achievement, maybe position, career stage, that would be that would be an indirect influence and have an indirect factor with relate to age. And I think it's a good cautionary example that we need to think about not only the things which are directly and obviously unfair when we engage in artificial intelligence activities, but also those things that have an indirect and distorting effect on the outcome.
Thank you. And we move to the last topic. Before we ask Nanda her opinion about the work, sustainable development. Henning, I think you start with this topic.
Yeah, thank you. And I think sustainability has a couple of sides, and if you don't mind, Jack, I start and then hand over to you. I think many of us, if not all, STM publishers are very active in the United Nations sustainability, sustainable development goals. Climate action, zero hunger, clean water, clean energy, a sustainable cities, and so forth. We all know that these big global challenges can be only solved by interdisciplinary approach. Now, the reality, I think, in science and research is very often still quite different. The disciplines are at times very siloed with different jargons and so forth. And the nice thing is, and I think we have seen that working, is that AI is able to cut through the disciplines. And this is really a strength of AI as we have seen it. And we should play out very strongly on it, overcoming the discipline boundaries. I think this is something which we really also should emphasize as one of the strengths of us in STM. If that makes sense, Jack, I think that is a segue into.
Yeah, I would agree, and I think this is one where I think Nanda's insights will be very valuable, because I know that a significant amount of her work is in the application of AI systems and how it can be done in an ethical and responsible way. So I want to make sure she has a chance to speak on that. The only example I would note that comes in in the white paper as a demonstrator of how AI could be used at a is in the UN Sustainable Goal 17, which is environmentally sound technologies. And that's something that needs the input from a huge variety and diversity of databases. And that's something that AI is well equipped to do, but it's also something where we all have to be very, very careful about the introduction of bias and distorting effects. But anyway, I want to make sure Nanda has a chance to speak about this.
Yeah, thank you. Thanks for this good overview. Nanda, could you tell us, first of all, about your fascinating role and your work in AI? And you had the chance to look at the white paper a bit earlier than others. Could you give us your view on this work?
Yes, thank you. And well, so a lot of expectations now with the way you introduced me, so I'm a bit nervous, getting nervous now. So what we do in Amsterdam at the Center of Applied AI is that we believe that that responsible AI and data science is not an academic study. It should be always in relation to the experts of a certain sector. So we only work in co-creation with people from this sector, and we have now 7 labs. These are labs in health, these are labs in media, labs in retail, and a couple of others in education. I can name them all, but that's not to the point here. What we are doing is we are applying AI in practice, and we do that, as you already mentioned, and I think John was in short cycle learning projects. So we always believe that you should do some experimentation, get the learnings, get the evaluation, and then continue with the learnings that you did from the previous cycle. And we do this also always with students, with partners, and in this way we would like to contribute to actual problems from our partners in practice. And meanwhile, as a research group, we study IT development, also practical guidelines for people and methodology that works. And we always complement it with training of all the partners, be it students, be it researchers, be it our partners. So I read your paper, and what I saw here is a very nice, project on translating AI ethics, the academic studies, to your sector. And I think you did a really nice job getting into like 3 main fields of application in data, in workflow, and in services of AI and digital technology. And I really appreciate that, and I think that's good. And what I felt with data, some things can't be fixed. You already mentioned that. If the data is corrupt, whatever intelligent model you build on it, it will never work. So that's a good idea. But then I question, I think that's the next step for you, is how do you find if data is trustworthy and of high quality? And I think that's need to be further developed and explored and putting into practical guidelines. The second thing that I always mention here is if you use AI for internal workflows, how does it relate to human decision making? We have a very nice application in the Netherlands for when the elections were here, everybody could fill out a questionnaire, online questionnaire, and it gives you the right party that you should choose with your statements and your motivation. And then I asked people, did you make the system decide for you? Did you use it as a confirmation tool? Or did you use it as an option tool? And then people were first confronted with the idea that if you use AI for decision making, you should relate it to your own decision making, human decision making. And I think that is also something that you need to further explore when you talk about responsible AI. Maybe I can continue just a little bit more on another topic here, and then I will give the floor to others and questions, please. When we work on AI ethics and we talk about responsible AI, and we want to get it to the workflow of what you're actually doing, then you see that the 5 components that you mentioned sometimes work on different level in your organization. So if you talk about the whole organization that you work for, you can say, are you a value-driven organization, or are you working for from human values, and you relate yourself to maybe EU rules or maybe social development, sustainable development goals? That is something that you put on a mission level or on the highest level. And then if you go to a certain organizational unit or a department level, then the human-centered AI becomes more in reality. So you have to determine your role and the framework that you work for, human-centered purpose of the tools that you need to make for the role that your department has. And if you then translate it to the process level, then you have certain checklists or frameworks that people can work with. So I think if you also continue to the next step from this white paper, you have a very nice overview of what ethical AI is for your sector, and you should now translate it to the 3 different levels in your organization.
Nanda, I was wondering, I mean, very intriguing just to take some of the things, the concept that you said of, well, you know, we need all of us to ensure quality. Are there any, and one of the things that the paper touches on is the value best practice guidelines, which can evolve over time. Are there any best practice guidelines to publishers? Because I think a lot of us are just sort of are into this in a relatively early stage. And so are there best practice guidelines that I, as a publisher, could refer to or look up or access that gives me some sense of direction or tips on how I can ensure that the data that I'm using is not only high quality but also unbiased? Are there any resources there that you can of which you're aware?
Well, there are a lot of books, and I looked it up just before this meeting, and that's why I was not in the screen again. Only last year, there were 9,643 academic studies on how to do ethical AI and data-related studies. So that's of no use at all. So what you need is the practical guidelines. And if you look at the practical guidelines, I think every consultancy firm has one now. And they're all of no use to your company if you don't translate it to your company. So there is no quick cure. There is no guideline that works for every sector, in my belief. And there are some overall principles, and you already showed them in transparency, openness, fairness, and bias checks, privacy. These are the main principles. But if you don't translate it to your sector, I think it will be worthless for the people in the workflow.
Thank you. And I think we just had a message from someone that noted the EU high-level expert group on the AI had come out with some guidelines that are probably worth noting for the group. I think I had another one, Nanda, and I know I always wanted to ask you this one. This issue of how much should human beings be involved in the development and the application of AI? You know, is it all machine? Is it all people? How much human involvement?
Well, there's different levels of human involvement in different stages of the process. I think when you give too much tasks to the programmer and the AI developer in deciding on what the system should or should not do, you give him an impossible or her an impossible task. For instance, when you have an algorithm that is a recommendation system, and you say, okay, I want to avoid people getting into filter bubbles. And then you said, okay, we're going to get trending topics, random selection, and some profile-related thing. And then there's a weight, and there are weights. And you ask the programmer to fill in the weights. And he or she will always do 30, 30, 30%, and 10%, I don't know. And this is a discussion that you can do with the users. This is a discussion or a decision that you can make with the product owner, with the users, and with the developers together. And that will make better products. So if you say human decision making in the development, you can, if you work in short cycles and you know, okay, I created a filter bubble, I have to fix that, go back and do it with all the users and to evaluate what can we do? Okay, we can use weights, what weights should we do? But on the other hand, there is a more disturbing idea, is that are we losing our ability to make decisions ourselves as human beings? If I ask my students to calculate 25 times 64, everybody will take the calculator. If I ask my mother, she will do it by head. And this is now a new topic that we should discuss. Will we as human beings lose our ability to make decisions if we ask everything to our automated systems?
But Nanda, isn't that the way technology is going anyway? Also outside of artificial intelligence, we lost so many abilities because technology helps us. Yeah, and I think there's despite all the risks that we are seeing, there's also a lot of benefit with really freeing up time to really become more creative, to do the stuff that is really not so tedious. And I think. Does that make sense? Or is that just too optimistic?
Well, that's the small AI, and I always say the system as a robot doing all our chores that we don't want to do, and that they can do very fast and more accurate and yeah, without any food or social context or toilet visit needed. But now we're talking about learning machines that are making decisions based on data that might have completely different ideas of what is right and what is wrong. So I'm now building together with my colleagues from the University of Amsterdam and the CWI, we are building an AI media and democracy lab where we want to see how automated systems in media may influence our democracy. And yeah, we have a lot of examples, especially in the United States, where you can get some, become worried. And then it's not a system doing a chore that we don't want to do, but it's actually influencing our the way that we feel, the way that we think, the way that we decide. So are we losing the ability if we are not very keen from the start of each project of what AI will do? And then I come back to my previous notion. Yeah.
Not as nice, so I thought it was nicer.
I have a question, by the way. If anyone in the audience has a question, feel free to ask it via the chat or just unmute. I have a question, Nanda, of the previous presentations of all the examples and looking at your ideas. Did you see any examples, and without, of course, criticize anyone, but where you think that certain feedback loops or certain principles should have been applied or should be applied, or where we should be careful?
Well, I'm sorry, I wasn't present at your previous meeting.
One thing, Nanda, I think you had some thoughts, and I found them very interesting in a session we had in preparation for this. I think you have some information to share with the group in terms of how, with whom should organizations be partnering, or organizations need to think about with whom they are partnering in the development of AI systems, and there may be some unintended consequences. You didn't say this, but I'll use as an example. So should I go partner with Google in developing my AI systems? Are there any pitfalls or concerns that one might have, or things of which an organization would need to be aware in looking at who are potential partners in developing AI systems? Or is that not a special, something special that we should be thinking about?
Well, if you look at the way that AI systems developed itself, it's the people who had the ideas, people who had the knowledge, and the people who had the means.
Yeah.
And if we look now at the system, we load our data into all different companies. So my personal address is with my insurance company, it's with my health company, etc. And from there, they started to work in clouds. And in the clouds, you say, okay, now I don't have to worry about anything anymore. Everything is safe, etc. And now there are also services that put it on top of that, saying, okay, I can analyze it for you. I can profile your customers for you. And meanwhile, our information is not owned anymore by each of us individually. And each of us individually can also mean me as a company. And if you don't own your data, you can think about, do I allow them to work on this? And we have a lot of law and legislation, but they don't, they are not up to all the innovations that are going on now. So I can give you an example from the Netherlands. I'm sorry, Netherlands again, but we allowed Tesla cars on the road in the Netherlands. And we have a government checking if the car applies to all the rules in the Netherlands. But you're not putting a car on the road, you're putting a computer on the road that you can drive with. And so the computer is updated, and within a couple of updates, there's a whole new product. And the government can't control this. They only did that at the start when they entered the market. So if you are thinking about your own systems, and the systems that you want to use and the companies that you are using to develop it for you or with you, you should also think about ownership. Who is owning it, the product? What is the use for the product? What is the other use for the product that I'm using? And the big tech companies, they have a lot of innovation power, and they can do anything that you can't even think about. So I think the rules and the regulations will change very soon, and I would hope that we will work in commons, or that we will work in getting people their own data logs where they only own their own data, and from there work further. So if we talk about the 3 levels of responsible AI, on an organizational level, you can decide what sort of companies and what sort of tasks you will want to use AI for. What companies do you want to work with, etc. But meanwhile, we are still working very hard on getting the guidelines, the frames, the checklist, and getting the bias data out of our system. So we have a lot of stupid work to do to get everything working that we want to do now. And meanwhile, we're also thinking about how do we want to continue from here.
Go on.
Right, Jack.
One of the things we all license text and data mining to various organizations, and now we have AI. I think a question that a lot of the people on this call get perhaps from people is, so what is the difference between text and data mining and artificial intelligence? And why is that difference important to me? Aren't they just the same thing, Nanda?
Depends on what you want to do with it. If you are saying text mining is a data set consisting of text, so it is a form of data mining. But it depends on what do you want to do with your text analysis. Are you profiling your customers? Are you getting better quality text? You are a publisher, so you want to have the best quality in the text that you publish. Depends on what you want to do.
So I know one question I wanted to ask you, Nanda. So where is all this going? Your work in terms of regulation and establishing the rules of the road, we've seen a lot of documents have been produced both on both sides of the Atlantic, investigations about this. Where do you see this all heading in sort of the, you don't have to go too far into the future, but at least over a planning horizon for companies, because we will not be operating in a vacuum, I think.
No, I think it's the same as in the Industrial Revolution. First, we were really happy that this was introduced and we were all using it, and we didn't see any of the pitfalls, and then we have to fix the pitfalls. I think where we are in this stage, that we all become aware that AI is not always responsible, and that the data that we use is not always the right data, and that it has some unwanted effects. So now everybody is trying to fix it, and meanwhile, if you're building new systems, make sure that we are not falling into the same pitfalls again. But where we are going, maybe for your sector, what I feel is really important is that you are working on a trustworthy science, and that is the STM, is on trustworthy science. And I think with this new technology that we have in AI, which is inclusive, everybody can get to all sorts of data and can publish themselves. They don't need the official publisher. You're getting in some sort of the same situation as the media is getting into, is that the trust of the people is diminished by people being able to publish themselves and to publish disinformation or to publish their own information. And that might be a really big, I think one of the biggest challenges also for publishers. How can we deal with an AI? It is going to be challenged. AI is not good, it's not doing the right thing, and at the same time it's being adopted. And so for you, the drive for commons approaches might be bottom-up data collections is going your way, and you're going to have the negative influences of people not trusting science. So we talk about trustworthy and high quality data, trustworthy and high quality publications. We need to uphold that and need to make sure that in this new world of AI systems and people being able to work on that themselves, also with low-level programming tools that are coming into this world, how can you become the trustworthy publishing company?
I think it's a fascinating remark, because as we saw from the previous speakers, having faith and trust in science is a challenge in itself. So will AI not make it even more challenging? We have two basically, science and AI to bring trustworthy. I don't know, Henning, and how do you see that? How can we, how should we cope with that as publishers?
Yeah, make it free for our researchers. No, I think this is a really big challenge. It's like the climate crisis that we have. We need to find new ways to do this. And I think being inclusive and being transparent is part of the being trustworthy, but also working in co-creation with the people who are influenced and affected by the science decisions and by the science that you are publishing, and not making it a sort of an overall elite. Science is for this elite group and they know best, and we set the research agenda, but start a conversation with people affected by the publications that you are putting forward and the data sets that you're putting forward. So create commons, create public debates. That might be part of the solutions, but I'm not sure we'll find new solutions, hopefully.
I think that's exactly what we wanted to also do with this white paper here. But what I specifically liked about the white paper is since I think Jack, you said that the technology is still evolving clearly. And I think we found a nice balance between, on the one side, raising awareness that we as STM publishers are very savvy about it. We're early adopters, but then also key partners to work with. But on the other side, also giving a number of best practice principles that give guidance. And I think on that latter point, we are not that far because we could not, and where, Nanda, question to you, where do you think we will be in say 2 to 3 years? Shall we reassess and then say what is the landscape, and and say if we can be a little bit firmer in terms of best practice guidelines towards ourselves and our partners.
Yeah, I hope you will get it short cycled, so 2 years at max to reassess where you are. And yeah, I think where will you be? You will be working very hard to get all the new innovations in AI working for your company in these 3 different fields sectors that you have. And this is not going to be solved within 2 years, but it's going to be something that we will work on for the next 20 or 30 years,
Sure.
and new adoptions all the time. So it's just like, now you assess the issue, you are aware, you are writing about it. I think you need to do a lot of training, a lot of connecting to all the stakeholders, and yeah, try to be as strong as possible to face all the challenges that are ahead of your sector, and don't become the record shop for CDs and be obsolete. I think that's the main challenge.
I think the working group just became permanent by that remark.
Nando, we had a question from one of the group that I thought was sort of an interesting one. And it said, basically, people, as we know, are not perfect. They make mistakes. They do have biases, even unconscious ones. And therefore, although we will be constantly striving to make sure that our AI outputs, and most critically, those that are advising us in decision making, or those that we are just allowing to make decisions, it will be extremely difficult, if not practically impossible, to eliminate bias completely. How do we live with that? How do we, come to grips with this fact that we are striving after a goal, which is very important, that we will never achieve?
Yeah. Compared to us, we have more than 300 sorts of bias. There's a great book about that. And then AI is our small child of 4 years old, making all the bias errors that we easily can detect. And yeah, we have to cope with bias all the time, but start eliminating the easy ones and the low-hanging fruit. And that's what we're doing actually with our AI systems and our digital tooling. The easy one that we can detect, we can eliminate now. But never think that we can eliminate all biases and all unwanted outcomes. But this system is still sort of a really basic robot that we are using. And yeah, we need to make it work and we can use it, but it can never replace us. That's science fiction.
I think that's a great ending of this session. It's the end of the session, but not the end of the work. I think that's the conclusion, and that's how the white paper is intended as a work in progress. So I hereby invite you for the session in 2 years from now on, discuss where we are and whether we are doing the right things. But
I would love to. Thank you for the invitation.
In any case, we hope the principles will help. So thank you very much for this very, very engaging discussion. The link in the white paper is just being added to the chat, so feel free to download it and give us all feedback, because that's really also what it's meant for. I want to thank all the speakers of this session, previous session, but the entire day. With this, we came to the end of today's session. I want to thank not just the speakers, the panelists, but also the program committee for, I think, a very, very nice session. I also want to thank the sponsors very much, Access Innovations, Area Systems, Research Information, and Strave. And we hope very much to see you at our next event, and then hopefully we can discuss digital and other innovations in a physical setting again. So thank you all very much, and hope to see you next time.
Bye now.
Thank you. Goodbye, Joris. Thank you.
All right, thanks, Henning.